All right, welcome back to part two of Building Mathematics, Secondary Math. So now we're going to talk about CRA, and it's my understanding that you've already had this in your math methods course, so this should just be just a quick review. So, CRA is an evidence-based practice for teaching students with complex support needs math skills. And as you may recall, it has three stages. And the first stage is concrete. And when I think of concrete, I always think of students as doing. They are doing something. And so, what they're doing is they're using physical objects, and in this case, it would be manipulatives, to create a model of the problem. And for this example, we're going to be using 6 plus 3. So that's what they're doing in the concrete level. They are creating models of the problem out of manipulatives. So if we were going to work with 6 plus 3, what we would do is give the student manipulatives, and then they would make sets of the counters. So they would make a set of 6 counters, and then they would make a set of 3 counters, and they would count both of those sets, and then they would combine those sets and then count the total. So again, when students are working at the concrete level, and this is where we start, when we are teaching a new skill, this is where we start, is at the concrete level, they are doing. All right, the second stage is representational. And you can think of that as seeing or drawing. And so this is where students transition from those manipulatives to things like drawings or pictures, and those represent the quantities of the problem or what you would have used the manipulatives to create. So again, it's a representation. That's how you can think of it. It's a representation that students are seeing or they're drawing. And so going back to our example of 6 plus 3, if they were at a representational stage for addition in this case, they would draw 6 dots, and then they would draw 3 dots, or they could use tally marks, or they could use a bar model, and then they are going to count the total of those sets combined. All right, now the third level is abstract, and this is a symbolic level. And you can see this gradually building. So when you think about scaffolding, if you are using CRA, you are scaffolding your students' instruction and their learning. So in that abstract stage of learning, they're moving away from any kind of representation that is either concrete or representational. Now they're moving to things like symbols and equations or numerical notations. And so when we look at our example of 6 plus 3, they would write the equation 6 plus 3 using numerals, and then they would solve it, and they would solve it only with those numerals. They would not have drawings, they would not have tally marks, nor would they be using any kind of manipulatives, for example. And so when we're talking about CRA, we want to realize that students can move up and down these stages at different rates. And so you may have students who are at a concrete level, and you may have students in the same class, in the same group, that are an abstract level. And this is why it is important that we differentiate instruction. And this is also important why we use things like UDL, because you can have students all along this continuum. Now, I do want to caution you because I've heard this from students before. Cut and paste activities are not concrete learning. Concrete learning is when you are using manipulatives, and those manipulatives, those concrete objects, are representing a model of the problem that the students are charged with solving. So you can see here that we have a cut and paste activity on the left, but that's not a concrete activity. That's a representational or a pictorial level activity. And then again, if you look at the right, it's a cut and paste activity, but this is obviously at an abstract level. So again, just kind of giving you a little caution about that. All right, so let's move into algebra. So when we're talking about algebra, we're talking about skills, and these are just some examples. There are more, but like patterning, relationships, or solving simple equations. And so using CRA, that's when we did our review, is a great way to support understanding with algebra. So you could, an example would be using the equation of 4 plus x, that's our unknown, equals 10 in a story about buying bagels. And you could start that off at a concrete level, so using manipulatives to represent that. Then, once students have become proficient at a concrete level, you move them to the representational level, where we might draw dots or tally marks, for example. And then, once they've got it at the representational level, we're going to move them on to the abstract level. But we always begin by recognizing patterns. And if you think about that initial precursor linkage level, that makes sense, right? That means that all students have access to learning algebra. And so some of the teaching tools that you might use when you're teaching algebra are manipulatives. I highly encourage you to start with manipulatives and then story context. So that's our math story based lesson. Because this is a way that you can transition from writing an equation such as 6 plus 3 to using variables such as 6 plus x equals 9. And so here's an example, and again, you're solving for unknowns there, and that x represents an unknown number that you're solving for, right? And so here's an example of a DLM essential elements related to algebra. So the students would use properties of operations as strategies to demonstrate that expressions are equivalent. And again, what you're going to do is you're going to look at your DLM essential elements and not only look at the standard, but look at those linkage levels so that you can ensure that all of your students have access to that standard. And again, what we want to make sure that we're doing is applying this to real life context. So introduce variables through real life context. So you might have a missing price. All right, so that's an example. And so again, we always want to make sure that we're tying our math to, some type of, and it's not as if you don't ever teach these skills in isolation, but as we're learning, we want to make sure that we're tying these to functional application. And so you can use strategies like CRA, and I'm not sure if you've heard, another one that you can use is called STAR. Those are mnemonic strategies. And STAR stands for search the problem, translate the problem, answer the problem, and then review the solution. Now, we're not going to go in depth on that because typically we're going to most often use CRA with our students. However, STAR we might use with our students as they develop those foundational skills. So an example of an algebra problem would be we have apples. So we have 4 apples. We need 10 apples. How many more apples do we need? Now, that is not a story problem because you realize that we're missing one of our sentences. Actually, that is one sentence as a whole. If it was a story problem or word problem, we'd break it up into 3 sentences. So it is a partial word problem, just to give you an example of what algebra might look like. But again, you're going to always start with those concrete manipulatives. You're going to fade to a pictorial or that representational level of math where they're seeing or drawing. And then finally, you're going to fade to the symbolic representation where they're using numbers. But I want to just remind you that I encourage you to write these story-based math problems because those model the problems. You could start by modeling solving one of the problems in your story even, and then follow by using that first story or that first problem as a template, and then follow through and create additional problems for the students to solve. But this really supports students in learning reasoning, and it's a great support for you as an instructor. So I do want to share with you and let you know that this is in the PowerPoint. It's a 10-step task analysis that's used to teach algebra. Now, I'm not going to go into depth right now on it, but I wanted you to know it's here and it's available to you if you are working or choose to work or think you might work later on a secondary level. I would highly encourage you to save this. Again, the PowerPoints I would download before the end of the semester if I were you. All right, so let's take a look at someone teaching algebra to students with complex support needs. But before we start, I do want to tell you this is not a good quality video. I just want to tell you that it's a little bit like jerky or segmented a little bit. And so but I want you to see what algebra looks like when you're teaching it to students with complex support needs. So we're going to use it even though it's not the best video. Oh, oh no, it didn't lead us to it. Let me try this. Here we go. All right, and this is from a example from the Attainment Company and a published curriculum called Teaching to the Standards Math. And so this is just a little bit of information in case you're interested. All right, here we go.
All right, we ready to talk about algebra today, right? Right. Algebra is a math that we use to solve problems. And today we're going to solve a problem about gift certificates for the movies. Irene wants to buy her friends a movie gift certificate at the mall. Irene already has one gift certificate. She needs to buy more gift certificates for her six friends. How many more gift certificates does Irene need to buy? So what is the problem? What are we trying to solve? What are we trying to solve for X? What's the thing we're trying to figure out?
Now you can see they're following a task analysis.
Number one, let's read number one. How many more gift certificates does Irene need to buy? And Sarah is correct. So let's listen carefully for the facts. Irene already has one gift certificate. She needs to buy more for her six friends. So what is our first fact? Yeah. Do you agree? One. Jabril, do you think it's number one? Yes. Absolutely. So where do we put number one? She needs to buy more gift certificates for her six friends. Okay. So do we know what our second fact is? Do we know what that information is? Should this be X? Is that what we're trying to figure out? So let's go ahead and put X where it belongs.
All right, so that's just a little bit of an example of how we might teach algebra. And you could see that they're following a task analysis, and I can tell you that that curriculum came from the task analysis that I shared earlier. So they're using a task analysis, and you can see they're using a graphic organizer. And again, when she starts with those students, she would use manipulatives because they would be at a concrete level, and then eventually move them up to a representational and then an abstract level. All right, so let's move on to geometry. So when we're talking about geometry, we're talking about skills like identifying shapes, positions, and spatial relations. And so when you're teaching geometry, you are going to be using some kind of tactile supports. So that could be foam shapes, you might be using puffy paint to outline things, because really what you use those for, those tactile supports, it could be blocks, is you're bridging that gap between the visual and that kinesthetic learning. And so in high school, one of the DLM essential elements for geometry is that given a geometric figure in a rotation, reflection, or translation of that figure, identify the components of the two figures that are congruent. Now, I'm sure that some of you are looking at that and going, I have absolutely no idea what that is. What do you mean I'm supposed to teach something like that if I teach high school? Well, now you can see why it is so important to go to the math experts in your class, in your school, because you can take this essential element to a high school math teacher and say, can you explain to me what this means? What does this look like? And so they would first explain to you what it means, just in general. And then I would say, can you use some kind of manipulatives to teach it? And then that teacher, that math expert, can help walk you through how you would teach this essential element to your students. So, an example of an activity you might do in class is using some kind of recycled materials to build a house, because that really can build an understanding of congruency. So, if we have a window on this side, we need to also have a window on this side. And again, that ties it to things that the students know in real life, again, recycled materials. So, just a kind of a reminder is that when you teach geometry, it is supporting students in understanding things like spatial reasoning. And when we think about being able to navigate through a mall, through a lunchroom, through a parking lot, we are actually applying skills in the math strand of geometry in a very functional way. And so, again, there's so many skills that geometry applies to building things. You know, for me, I'll give an example. I recently bought a house, and I am using geometry to help me decide where to put things in my home as I'm decorating. So when you're teaching geometry, you want to make sure that students are identifying, building with, and manipulating some kind of shapes. That's what they're doing with geometry. So again, an example might be constructing a floor plan. You can have the students create a model of your classroom, a floor plan, and then use foam shapes to represent the items in your classroom on your on your floor plan. And so if you look at the DLM essential elements, you can see alignment across all grades in geometry standards. And so what you do is they're building on one another. That's why we don't ignore our standards in our earlier grades. We make sure that we hit our standards because if they have a standard, if students have a standard in geometry in second grade and you don't cover that standard, well, guess what happens when they get to third grade? They're not prepared for the standards in third grade because they don't have that foundational knowledge. But I would encourage you that when you're teaching geometry, because we are going to make sure that we align and make connections with real world, problems, real world situations, and so students can apply geometric skills or geometry skills in functional situations. I encourage you to tie geometry to navigation. You can set up a pathway, an obstacle course to art. Art includes a lot of geometry or any kind of design. Again, if you're in high school, you can have students build their own apartment. And what would it look like? Or what would your bedroom look like if you were to live in an apartment? And let them do that design themselves. All right, what we're going to do now is, and I'm going to have to click out of this, we're going to now watch a portion of a video on students learning geometry and a teacher who was teaching students with complex support needs these secondary skills that in the past people thought they weren't capable of learning, and you'll see that they are. Again, these videos are not the best. I apologize. And again, this is from the Attainment Company, and it comes out of the published curriculum, Teaching to the Standards. And all of these videos, if you want to watch them later on, are on the Attainment site under the published curriculum. So here you can see again what is included in that curriculum, and I want you to notice story problems. That's why we're pushing that. I'm teaching to you now. All right, let's look at geometry.
Lesson on geometry. We're going to go over some vocabulary words first. We have the word plane. Plane. This is plane A, B, C, D. This is the word plane. A plane is a flat surface made of points. Hunter, can you point to the picture of plane? Good. Alicia, point to the picture. Good. Okay, this is the word plane. Can you point to it? Can you say it? Can you guys open up your books to page 8 so we can talk about Kurt going to the grocery store? First thing, we have a map over here. We're going to use our map of the grocery store to help us solve our problem. And we have different points on our map. We have point D, which is the dairy section. We have point P, which is the produce section. Point B, the bakery. Point A is where we enter and exit. Can you put your finger on point A? Our word problem today says, Kurt plans ahead. Kurt needs to buy food to make breakfast and lunch this week. He needs oranges, ham, and milk. First, he gets oranges. The question that we're trying to answer is, what food does Kurt get next? Hunter and Alicia, can you mark what food does Kurt get next?
All right. So again, that's only part of a lesson, but the intent is to show you that our students can learn these skills when we teach it to them. But what I hope you noticed with both of the videos is they're using some type of like graphic organizer, and they're using a math story-based lesson. And if you notice, this is of high interest, and it's something that the students understand and are connected with because they've all been to the grocery store before. All right, let's keep going. I want to do a quick check-in with you. How do you feel so far about algebra and geometry? You feeling good? I'm getting it, but need some more time, or I'm completely lost. Make sure, as always, that you include your questions either in your discussion guide, your participation, or that you make sure that you send me an email with them or ask them in class. All right, that is the end of video 2. Did a little bit better on the time on this one, and I will see you in our next video.